everyone, welcome back to my channel. I'm Preeti. I'm a first year computer science and engineering student at Venkateshwara College of Engineering, Bengaluru. Today we are discussing about estimating the approximate area, volume and surface area under the guidance of Dr. Kavita BN. Introduction to Estimating Geometric Properties. This presentation will explore techniques for estimating the approximate area, volume and surface area of various geometric shapes and objects. Understanding these fundamental properties is crucial for engineering, construction and many other fields. In today's lineup, we will cover defining area, volume and surface area, calculating the area of 2D shapes, volume of 3D shapes, surface area of 3D shapes, and then approximation techniques for complex shapes, factors affecting estimation accuracy, practical application of geometric estimation, estimating irregularly shaped objects, and then conclusion and key takeaway from the session. Defining area, volume and surface area. Area. Area is a two-dimensional measurement that describes the size of a flat surface such as a square or a circle. It represents the amount of space enclosed within a shape's boundaries. Volume. Volume is a three-dimensional measurement that describes the amount of space occupied by an object such as a cube or a sphere. It represents the capacity or size of a three-dimensional shape. Surface area. Surface area is the total area of the outer surface of a three-dimensional object. It represents the total amount of area covered by the shape including all its faces and sides. Calculating the area of 2D shapes. Rectangle. Calculate area by multiplying length and width. Circle. Find the area using the formula pi r square where r is the radius. Triangle. Use the formula half into base into height to find the area. Calculating the volume of 3D shapes. Cube. The formula for the volume of cube is simple, that is V is equal to s cube, where s is the length of one side. This makes it easy to calculate the volume of cube once you know its dimensions. Sphere. To find the volume of sphere, use the formula V is equal to 4 by 3 into pi into r cube, where r is the radius of the sphere. Spheres are often used to model 3D objects like planets and some molecules. Cylinder. The volume of a cylinder is found using the formula V is equal to pi into r square into h, where r is the radius of the circular base and h is the height of the cylinder. Cylinders are useful for modeling objects like cans, pipes and drums. Pyramid. The volume of a pyramid is calculated as V is equal to 1 by 3 into A into h, where A is the area of the base and h is the height of the pyramid. Pyramids are found in nature and in architectural structures. Calculating the surface area of 3D shapes. Determining the total surface area of 3D objects is crucial for various applications such as packaging design, heat transfer analysis, and material usage optimization. The key is to identify the geometric properties of the shape and apply appropriate surface area formulas. Common 3D shapes like cubes, spheres, and cylinders have well-defined surface area equations. More complex shapes may require breaking them down into simpler components or using numerically approximation techniques. Approximation techniques for complex shapes. Polygon approximation. Break down complex shapes into a series of simpler polygons, then calculate the area and volume of each polygon to estimate the overall geometric properties. Finite element analysis. Divide the shape into a mesh of smaller elements and apply mathematical models to estimate the area, volume and surface area of the entire shape. Integration techniques. Use integral calculus to approximate the area under a curve or the volume enclosed by a 3D surface, even for irregularly shaped objects. Factors affecting estimation accuracy. The four major factors are complexity of the shape, available information, estimation technique used, human judgment and experience. The first one is complexity of the shape. The more intricate and irregular the shape, the more difficult it is to accurately estimate its geometric properties. Available information. The amount and quality of data, such as measurements or diagrams, impacts the precision of the estimation. Estimation technique used. Different mathematical approaches like decomposition or integration, yielding varying levels of accuracy for complex shapes. Human judgment and experience. The estimator's skill, intuition, and prior knowledge play a significant role in the reliability of the results. Practical applications of geometric estimation. Construction planning. Estimating the dimensions and volumes of building components is crucial for accurate cost projections, material requirements, and construction feasibility assessments. Medical device design. Geometric estimation is essential in designing prosthetics, implants, and other medical devices to ensure optimal fit and functionality for patient needs. Engineering calculations. Estimating the surface area, volume, and other geometric properties of complex systems is vital for modeling simulation and performance analysis in engineering projects. Packaging design. Careful geometric estimation is required to optimize the size, shape, and material usage for product packaging, ensuring efficient storage, transport, and display. Now let's see how to estimate irregularly shaped objects. Approximation. Use geometric formulas to estimate. Measurement. Take physical measurements where possible. Visualization. Imagine the object broken into simpler shapes. Estimating the geometric properties of irregularly shaped objects can be challenging, but a systematic approach can provide reasonably accurate results. Begin by approximating the shape using basic geometric formulas, then take physical measurements where feasible. Visualizing the object broken down into simpler composite shapes can also aid in the estimation process. And now we are at the end of today's session, so let's summarize the core concepts covered in the presentation, highlighting the 5 most important points. In conclusion, we have explored the fundamental principles of estimating geometric properties such as area, volume, and surface area. By understanding the calculation methods for 2D and 3D shapes as well as techniques for approximating more complex form, we can apply these skills to a wide range of practical applications. The key takeaways are defining and distinguishing between area, volume, and surface area, calculating these properties for basic geometric shapes, employing approximation strategies for irregularly shaped objects, recognizing factors that impact estimation accuracy, identifying real-world use cases for geometric estimation. These concepts provide a solid foundation for further exploring the world of quantitative analysis and design optimization. I encourage you to apply these principles in your own work and continue expanding your knowledge in this fascinating field. Thank you for watching. Please do like and share the video.